Hello everyone, and welcome to this explainer. I am absolutely thrilled you're joining us today. We're talking directly to the cloud architects, the platform engineers, the DevOps practitioners, and the SREs out there who are navigating, well, let's just call it the immense, sometimes chaotic complexity of modern infrastructure. You know, for years we've relied on traditional CI/CD pipelines to manage our deployments. And let's be real with each other. We all know the headaches that come with those legacy models. I'm talking about silent configuration drift, well-intentioned but super messy manual kubectl interventions during a late-night incident, and those incredibly fragile push-based deployment scripts that always seem to fail exactly halfway through. Well, today, we are going to completely unpack the solution to those problems by exploring how ArgoCD mechanically powers GitOps deployments. If you've been looking for a clear, structured breakdown of how to bring reliable, self-healing automation to your Kubernetes operations, you are in exactly the right place. Here's our quick roadmap for today's explainer. We're going to start with a look at the GitOps operating model, then introduce the engine itself, ArgoCD. We'll walk through the exact workflow, look at core capabilities and recovery, and finally, scale it up with platform engineering. Let's jump right in.
All right, Section 1, the GitOps operating model. Let's lay down the theoretical foundation here.
Okay, let's dive into this. GitOps has fundamentally transformed how we handle infrastructure management, and the core philosophy is brilliantly simple. It is all about treating Git as the absolute, unquestionable, single source of truth. Actually, scratch that. It's not just a source of truth, it's the only source of truth. In a traditional CI/CD model, your deployment scripts push changes into a cluster, right? But over time, what is actually running in that cluster inevitably drifts from what was in the original script. Someone jumps in to make a quick hotfix in production, and boom, suddenly your environments are completely out of sync. By moving to a declarative model where your entire infrastructure state lives inside a version-controlled Git repository, you eliminate that ambiguity entirely. You gain absolute consistency across your environments and flawless auditability, because every single change, whether it's a huge application update or just a tiny resource tweak, is permanently tracked as a Git commit. But you know, theory is just theory until you put it into practice. GitOps needs a mechanical enforcer.
Which brings us to Section 2. Enter ArgoCD, the engine. This is where we pivot from cool theory to practical necessity.
So what is ArgoCD exactly? Well, it's an open-source GitOps continuous delivery platform designed natively and specifically for Kubernetes. Think of it like the mechanical engine under the hood of your GitOps vehicle. Now, what's really fascinating about this, and absolutely crucial for enterprise teams, is the massive security upgrade it provides over traditional deployments. Think about legacy models. Your external CI server requires admin-level God mode credentials to push into your production clusters. That is a massive attack surface. ArgoCD flips this entirely by utilizing a secure pull model. ArgoCD actually lives securely inside your Kubernetes cluster. It doesn't need open firewalls for incoming traffic. Instead, it reaches out to securely pull your configurations from Git. It acts as this always-on, highly secure observer, ensuring that your architectural theory is actually enforced in reality.
And that brings us to the absolute core problem ArgoCD solves, bridging the gap between your desired state and your actual state. On one side, you have your desired state. This is what you want to happen, safely stored, versioned, and approved in Git. On the flip side, you have your actual state, what is literally running live in your Kubernetes cluster right now. ArgoCD manages this through what we call a continuous reconciliation loop. Under the hood, the ArgoCD application controller is constantly pulling your Git repository, generating the expected Kubernetes manifests and mathematically comparing them against the live Kubernetes cluster API. Whenever a difference pops up between these two states, ArgoCD instantly identifies the drift and automatically reconciles it. It physically forces the actual state to match your desired state. No more guessing games.
Moving right along to Section 3, the ArgoCD workflow walkthrough. Let's visualize this whole end-to-end lifecycle. Let's organically trace the journey of a code change through this system. The workflow always starts with a developer committing a change. But there is a super critical architectural best practice here, and honestly a really common implementation mistake to avoid. You have to ensure you separate your application source code repositories from your Kubernetes manifest repositories. Why? Well, if your CI pipeline builds an image and writes the new image tag back into the exact same repo that triggered the build, you just created an infinite loop. Not good. So, the developer updates the code, the CI pipeline builds the container image, and then it automatically updates a distinct Kubernetes manifest repository with the new image tag. That manifest repository is our isolated single source of truth.
Then, ArgoCD, sitting safely inside the cluster, spots that new tag in the manifest repository, pulls the declarative change and deploys it. It's a completely automated, reliable pipeline where your infrastructure repository stays totally pristine, isolated from the noise of constant application builds.
Let's break this down into 4 really concrete steps to cement it. Step 1. The code is committed. Step 2. A pull request is reviewed and approved in Git, updating the desired state. Now, pause here, because this is a massive paradigm shift. The PR in Git literally is the deployment. Your code review and your infrastructure deployment review are now the exact same event. This enforces strict governance and auditability. Nobody can sneak around the process to alter production. Step 3. ArgoCD detects the update and syncs those changes. And Step 4. The Kubernetes cluster is perfectly aligned. By structuring it this way, the massive manual burden of executing deployments is completely lifted off the engineering team's shoulders.
Section 4. Core Capabilities and Recovery. Let's look at the specific features that make this an absolute game changer for SREs.
So the really crucial point to remember is that ArgoCD isn't just some fire-and-forget deployment script. It gives us 4 operational pillars that fundamentally change how we manage reliability. First up is continuous synchronization, which just ensures your clusters stay perfectly aligned with Git. Second is drift detection, and this brings the magic of self-healing. Imagine a rogue engineer or a compromised process manually deletes a critical pod or edits a config map directly in the live cluster. ArgoCD instantly catches that deviation and immediately overwrites it back to the exact state defined in Git. Third is rollback simplicity. You can totally forget about complex, chaotic rollback scripts that you just pray still work during an outage. With ArgoCD, reverting your infrastructure is literally as simple as running a standard git revert command. The second that commit hits the main branch, ArgoCD rolls the cluster back. Finally, deployment visibility gives your operations teams a real-time, centralized dashboard of application health across your entire fleet.
Finally, Section 5. Scaling with Platform Engineering. Let's zoom out to the macro level for massive enterprise environments.
If you are a platform engineer tuning in, this right here is your reality. Modern Kubernetes environments are incredibly complex. We are rarely dealing with just one cluster anymore, right? We're talking about multiple clusters spread across different geographic regions, maybe even spanning different cloud providers. Trying to manage this manually is a recipe for absolute disaster. And this is exactly where enterprise adoption patterns for ArgoCD really shine. Large organizations typically deploy a centralized ArgoCD management cluster, basically a hub-and-spoke model. This single hub cluster reaches out and securely orchestrates deployments across dozens of remote worker clusters. It completely standardizes your entire global fleet from a single, unified control plane.
Because of that incredible scale, platform teams are standardizing ArgoCD as the beating heart of their internal developer platforms. This integration obviously gives you standard deployment workflows, but it also dramatically improves your security governance. ArgoCD integrates beautifully with enterprise single sign-on and uses really granular role-based access control, or RBAC. This means your platform teams can confidently give developers access to deploy their own apps, but strictly restrict them to syncing only their specific namespaces. It totally prevents anyone from accidentally breaking core cluster infrastructure. You get vastly reduced operational complexity, and honestly, most importantly, you deliver a much better developer experience. Developers can just merge their code and trust the engine to handle the heavy lifting.
This quote perfectly summarizes everything we've been unpacking today. GitOps provides the operating model. ArgoCD provides the execution engine. They really are two halves of the same coin. Together, they are exactly what enables reliable, highly secure, and deeply scalable Kubernetes operations in the modern cloud era.
As we wrap up this explainer, I want to leave you with a few rapid-fire, practical recommendations for adopting this in your own org. First, start small. Pilot ArgoCD with a non-critical stateless application before you try moving your complex, stateful workloads. Second, standardize your configuration management. Pick either Helm or Customize and stick with it across your teams. And third, enforce strict Git branch protections so that absolutely no code reaches your manifest repositories without approval. If your deployment pipeline is declarative, automated, and self-healing, if ArgoCD is automatically keeping production perfectly aligned with your single source of truth, what other manual, time-consuming cluster operations are you ready to completely eliminate today? Thank you so much for joining me in this explainer. I really hope this deep dive gives you exactly what you need to optimize and secure your cloud-native deployments. Keep learning, keep automating, and I'll see you next time.